Everyone for joining us at this industry session. We're going to structure it the same way we did the opening session. We're first going to have the panelists introduce themselves, tell us a little bit about their educational journey, and then we will open it up to questions. So I'd like to start with our remote panelists. So why don't we start, Dr. Gordon, why don't you tell us a little bit about, just briefly introduce yourself, your position, and your educational background.
Sure. My name is Kelly Gordon. I work at Black & Veatch in Kansas City as a process engineer on the wastewater side. I received my PhD from Notre Dame with Rob Nirenberg, and then I went in, I had a postdoc with Nancy Love at the University of Michigan. And then I came to Black & Veatch. I was interested in applying my knowledge to solving real world challenges. And I also found that with my position, there were a lot of availability to live where I wanted to live. That was pre-COVID times. So.
Thank you, Dr. Gordon. Now from Dr. Rosenfeld.
So I'll do it right this time. I'm Eric Rosenfeld. I'm an associate vice president and the national leader, the leader of our national drinking water practice group here at Hazen and Sawyer. I got my BS in chemical engineering from Washington University in St. Louis, and I'm very eager to be back there. I wish I could be there right now. I should be there right now, but my flight last night got canceled, and I'm actually going to be heading to the airport in near the end of this session to try to get my way out there. So I'll be available to talk further this evening or at any time during the conference. So I should see you guys soon. I worked for a few years after my BS, and I went back to school and got my master's and PhD in environmental engineering, working with Carl Linden at Duke University before he left to go to CU Boulder. I did a brief visiting scholar, two brief visiting scholar stints, one at IAVAG in Switzerland and one at North Carolina State University working with Dr. Detlef Knappe. Upon graduating, I went and was an assistant professor at the University of Massachusetts for several years in the Department of Civil and Environmental Engineering, and went from there to help start an applied research group at Hazen and Sawyer. And since joining Hazen in 2010, I've risen through the ranks to where actually just 2 weeks ago, I was named the national practice leader on the drinking water side.
Thank you. And now we'll turn it over to our in-person panelists, Dr. Bott.
All right, good morning. My name is Charles Bott. I'm currently serving as Director of Water Technology and Research for Hampton Roads Sanitation District, which is the wastewater utility that serves about 2 million people in Southeast Virginia. I'm going to take that down for this. We have kind of a big distribution of plants and technologies. We have now 18 treatment plants ranging from 25,000 gallons per day to 54 million gallons per day. My educational background, I did a bachelor's degree in civil and environmental engineering at Virginia Military Institute, then a master's degree at Johns Hopkins in environmental engineering, and a PhD at Virginia Tech. I worked a little bit after my bachelor's degree for a small firm in Richmond doing actually mostly landfill work. And then I went at Virginia Tech. I did my PhD working with Nancy Love there. After that, I actually went into consulting and worked for a firm called Engineering Science, which got bought out by Parsons. It was well known as kind of a boutique, very technical environmental engineering firm doing mostly water, wastewater, solid waste work, and got kind of folded into Parsons. From there, I actually went back into academia and took a position back at Virginia Military Institute. Stayed through the tenure process, got tenure, and decided to leave, which was crazy, but I did, and also started a joint position at Virginia Tech at the same time, having Virginia Tech students working with me on research work there. So I took a job as this director of research at HRSD, and I've been there ever since, and have maintained positions at Virginia Tech and Old Dominion University so that we can host graduate students at our facilities working with us on their research projects.
And then our final panelist, Dr. Abram.
Okay.
Thank you. I'm going to go in and out. I had sort of prepared something a little differently because I didn't. Yeah, I know, but I'm gonna have to do it if you don't mind. Okay. And I'm going to just go in and out of my presentation. I introduced myself earlier, so I'm not going to do that now. And what I would like to do is just, I'm going to go in and out of talking about, because I thought this was more about how I got into the piece of the environmental profession where I specialize. I used to be a university professor, so what I'm going to do is just sort of open up some of the things that I think this is about is, if I can see, how do I advance this? Here's some of the options that I just would like for you to think about. And then we can turn it off. Is some of the options that you have available to you. The environmental engineering profession, I think you heard me say earlier, has really evolved from the time that I got started. I got my bachelor's degree in 1966, and there's been a lot of movement, and I think it's wonderful. My master's degree is in sanitary engineering, and the focus was really more public health and more sanitary, and then it evolved. Over time, when I was in academia, it then became civil and environmental engineering. And over the years, we have found ourselves moving further and further away from civil engineers. And now we're becoming environmental engineering and science. But in between there, I got my PhD in chemical engineering. And why was a PhD in chemical engineering? Because there were no PhDs in environmental engineering when I got my PhD in 1972. And so many environmental engineers, the sanitary engineers, have their PhDs in chemical engineering because we use unit operations and unit processes to do the treatment for many of the environmental problems that we were solving. I hear that Washington University is now getting ready to go back to chemical engineering, environmental, and health in a very big way, and that is the movement of our profession. Now we have environmental engineering standalone, environmental science standalone, and I'd like for you to know that we are getting ready to get our first ABET accredited environmental science program. So our tent is big, and we are very happy for that. What can you do? What are your career options? These are all of the things that you can do with your degree. Many of you, PhD, what am I going to do? The world is open to you. With your skills and your training, the environment is first and foremost. Here are some of the options. You don't just have to be a university professor. You can teach in K through 12. You can do what I do. You can be a practicing engineer. You can go into industry. You can be a medical profession, and God bless, a politician. So these are just some of the options that are available. And these are some of the things that we will explore. And I'll be happy to talk about more as we progress in this discussion. Thank you. You can close.
Thank you, Dr. Abram.
Right, so we'll just quick follow-up question for all of our panelists. Actually, two questions, because I'm actually curious about this myself, and I think this might help some of our audience members. The first question is, what do you love about your job? Followed by, what is just one skill that you learned as a graduate student that has benefited you in your career? So Charles, do you want to start us off? So what do you love about your job? And what is one skill that you learned as a graduate student that benefits you today?
Okay. Well, first of all, I feel like I've got just the ideal job. So I absolutely love what I do. And basically I do exactly what I want to do, and I don't have to do anything that I really don't want to do. And that's so that makes it, it's not like work. I often say I would do half of my job for free if I could just the other half, have a little bit less time at work. But so the reason is, I have the opportunity to be a technical director for this organization, serve as basically a director in charge of basically what we're doing from a technical standpoint. And I run a research program, which is mostly graduate students with a few process engineers that don't really report to me, but are really highly qualified. So I get to do all the research I want to do, all the interesting work I want to do, and guide what we're doing at our treatment plants without having to manage, 600 people and all of these treatment plants and all of these people and day-to-day problems and budgets and all that stuff. So it's really awesome. So I feel quite fortunate in that regard. One of the things that I think, so this was what I learned in graduate school. So one of the things I think that at least we learn as PhD students that we don't get, maybe some people do, but often not, is really how to dig in and really identify what the problem is, then set about solving it. It turns out that a lot of people, they kind of, a lot of people I notice that are educated engineers, they sort of, when things are complicated, they sort of wander around the problem without really taking the time to just first figure out what is the problem that we're trying to solve. And then once we can articulate that problem and identify exactly what that problem is, then we start the process of solving it. It's really interesting to watch young engineers do this and work on this quietly from the sideline. Because what I often see is those folks that have gone through a PhD program do an excellent job of that, and it very much sets you apart. You just have to, I think, do what comes natural, not what comes natural to you after going through a PhD program.
Oh, you want me to come next? Okay. One thing I learned in graduate school in environmental engineering is that, unfortunately, men don't get it. It's all about, what we do is all about people. The engineering is so easy, relatively speaking. It's making the project work for the project beneficiaries and getting the beneficiaries to accept it or to be a part of it. That's the hard part of what we do. One of the things that I enjoy doing is solving problems of the human environment. Project I worked on quickly for 20 some years and still work on is I solve problems of people in developing countries. My company does a lot of work in the US, but I do a lot of international work. And when Nelson Mandela became president, he told President Clinton, I want some of your engineers to come and help me rebuild my country. I knew he was talking to me. I knew he was talking to me. And I knew how to solve that problem in many ways: housing, water, sanitation. We demonstrated over 20,000 passive solar built homes. Environmental engineers know how to do this, but the woman, the lady that lives in that house, was never asked, how do you want to live? We engaged the women, the community, and you should see the outcome. I had 2 people and we have 30,000 homes. We are now working on sanitation. Everybody needs drinking water and everybody deserves the right to go to the toilet with dignity. And women should not have to go to the toilet afraid and fearful and end up using a bucket. These are the problems that I solve, and that's what I look forward to. Men don't get it, but they are coming around. Your children get it, but my age did not.
Thank you. Dr. Rosenfeld, what do you love about your job, and what is one skill you take into your career that you learned as a graduate student?
I thought about it a little bit differently because I mentioned what I loved about my job on the last panel. I thought about answering this question about what makes a good day at my job. And I think doing things like working with people like Charles makes a good day, getting to come up with ways to make some of his ideas that he explores come to life is really interesting. And utilities like HRSD that have cutting edge interests and concerns, and trying to work with them to come up with ways to make those innovations happen is one of the great things of my job, and really one of the things that I love about my job. One of the more important things, skills as a grad student, was to keep a practical eye on everything we're doing. It's really easy to get very, very deep into your PhD work and to focus on answering that one little question exactly perfectly. But it's very important as engineers to think about how that connects to the broader phenomenon, to the broader world, and even get into things like how it affects people down the road. So that's an important thing that I learned, an important skill that I learned during my PhD was, answer the narrow questions, but keep the broader perspective in mind.
Thank you. Now, Dr. Gordon.
Sure, and I'll probably just echo that. Really, it's enjoying the people that I work with that gets me the most excited to get up and work in the morning. So I enjoy working with both the clients and with my internal teams at Black and Beach, but just speaking more in regards to the internal teams, I love that I get to work with people that are thought leaders in biosolids, in structural engineering, in architectural engineering, in mechanical engineering, and we all come together to solve a client's problem. So it is fun working on multidisciplinary teams on a daily basis. And then in what I took away from my PhD, I think when I first started in consulting, I thought, okay, they must have like a handbook where step 1, step 2, step 3, step 4. And you know what? There are still so many unanswered design technical questions at drinking water and wastewater treatment plants. And so understanding as a PhD how to answer the unanswered questions, either through doing your background research and performing a literature search, and also seeking out the experts in the field and talking to them about your problems. So yeah, I think learning how to learn, basically.
Yeah, thanks, Dr. Gordon. Okay, that was the softball questions for our panelists. Now y'all are gonna ask the hard-hitting questions. So who has a question? Who can get us started? We have one over here. And if you want to just mention your name and affiliation first.
So hello, everyone. My name is Kwang, and I'm from Oregon State University. I have a questions. So I feels like there's tremendous pressures after graduation from your PhD to become an assistant professor. I could not imagine the stress, like for my advisor. What are there any obstacle for the transition from academia to industry and vice versa? And is there, what are the challenge and benefits of that? Thank you.
Okay, great question. Would anyone like to start? If not, I'll pick one of you. Okay, Eric, you've been nominated.
The easy one. I thought I finished answering this question when I went to this conference in Tampa about 6 months after I made the transition from UMass to Hazen and Sawyer. So the question is transitioning between academia and industry. I've kind of floated back and forth or tried to float back and forth. I started in academia and then I went to industry. For me, I don't know that would have been an easy transition if the work I was doing in academia wasn't as practical as it was. There's a skill set that's required that's a little bit different in industry than it is in academia. And I got the opportunity to move to industry because of, some of the work that I was doing in academia. So That for me was easy. I don't know that that's as easy for everybody. I've entertained a few opportunities to go back to academia since starting here at Hazen, and I hope, I mean, over the years I have. I think we all think about the grass being greener at times. And with those opportunities, I've interviewed for a few of them, and I was offered one. I guess the ones that I didn't get offered, the main flaw in my resume was a lack of publication, or a gap in my publication record, which I think is a reality that's difficult to overcome when you go into industry. So, again, we spoke about work-life balance and the thoughtfulness that has to go into that. Well, the same thing, if academia is something that you're interested in, I'm engaged in lots of projects that we could write papers about and should write papers about, but you make this choice about whether you want to take the time to write that paper or move on to the next interesting project. And, I think if you were thoughtful about it and made it happen, as a practitioner, you have a very, very good skill set to provide in academia. Practical knowledge base that is invaluable for the student to learn from. So, it seems like it could be a logical thing to do, but there are challenges, and you just have to be thoughtful about how you're pursuing your career if that's an option that you want to entertain.
Yeah, thanks for that. Dr. Abram?
Thank you. My track was academia. That's the reason why I have a PhD. And I was going to go all the way from chairman of the full professor to chairman of the department to dean, provost, and university president. That was what I wanted to do. And I got my PhD in 1972. And I went into academia. I taught at Tennessee State, Vanderbilt, and then Howard. And it became very obvious along the way that I was not going to be successful in my chosen area. And that's what you have to think about as you move along the way. Are you going to be successful in this or not? Why was I not going to be successful? Because I was a female, and a Black female at that. And most of the professors in engineering schools during that time were foreign. Very few Black professors and no women. So it was going to be difficult, and I like to move around. I like to do things. I like to solve problems. I'm not necessarily that lab type of person. And all of the professors had engineering consulting firms on the side, and I would work on the side. That was frowned upon. They could do that, but I couldn't. And after a while, I had to make a decision. You've worked too hard. What are you going to do? So I came out, not because I wanted to, but I had to. And I'm happy that I did. But you have to face the hard choices at times and don't wait too late. It was easy for me because I'm easy. I can do anything, but just don't wait too late.
Kelly, go ahead.
Okay, I just wanted to give my response right now because I do have to leave at 10:30. So I would just say, first and foremost, there are endless number of opportunities, an endless number of challenges. And I think you can go many different pathways in life, but they all will be enriching and fulfilling experiences. So I do think, there's more than one pathway for all of us to have career success and fulfillment. But in terms of when I joined this consulting firm, I did have some, more applied research as part of my academic background. But I remember one of the first days I showed up and they're like, well, how would you design this flow splitter box? I'm like, I don't know anything about splitter boxes. Even what is a flow splitter box? I think sometimes when you have, PhD after your name, they think that you know a lot more than you do when you kind of just know something have a depth of knowledge in a specific area. So I do think there is a knowledge gap that you have to catch up in regards to that when you're joining from academia. Also, I had to learn about time management and not having, as much time as I wanted to dig into a certain project or a problem, a subject area. And then 3 is communication, being able to communicate to multiple different groups of people. So being able to communicate to other academics, being able to communicate to operators, and being able to communicate to plant superintendents, you need to understand what each group is interested in hearing about and in which level of detail. But I think what I brought to the table is understanding how to answer, like I said, some of these questions that still exist, and how to, when you run, for example, bench scale reactors or pilot scale reactors, you understand the challenges, and both with sampling, testing, getting reliable results, understanding what is quality data, interpreting results, analyzing, et cetera, that other engineers or undergraduates, that may come straight out of an undergraduate degree may not understand. So I want to thank you all for letting me join today, and I'm sorry that I have to leave halfway through.
Okay. Well, I guess I'll start by saying I've floated between industry and academia as well. And I'm still not sure exactly what I want to do, but when I was doing my PhD, I knew at that time I was not passionate about doing the assistant professor thing at a big research university. I was really doing relatively applied research work on the wastewater side, similar to Eric on the water side, and both industrial and municipal focus. And I had an interest in going out and doing kind of some interesting projects. And what I learned is that and maybe this is harsh to say, but with a PhD, going into consulting, you kind of automatically get your foot in the door. After that, it's up to you. But you get a chance that maybe others don't get, and you get a chance to demonstrate what you can do, but you have to do it quickly and be useful quickly. It's fun. It's a lot of fun. There's all of a sudden you find out you're working on 15 projects that are all super interesting all over the place, and it's more, all of a sudden you're doing more than you can handle. And so it immediately goes from 0 to a really big, busy life in a hurry. But it's exciting. And one of the things that I learned immediately upon doing that was that we should always remember to fall back on good fundamentals, good science and good engineering fundamentals, and don't be sort of taken down the track of getting stumped by not remembering that we know these fundamentals and we need to always make sure that we fall back on them. And I had 2 good mentors immediately from day one in consulting that tested people that way all the time, and you had to see through it and, okay, well, this doesn't make any sense because it just doesn't follow what we know it should from fundamentals. And that's something that coming out of graduate school you should just always remember. And if you feel like you're not strong in some areas, you just need to get that way, right? So yeah.
All right, thank you. We have plenty of time for more questions. Yes, we have one right here. Oh, okay, one over here first, and then we'll come to you next. Right here in the blue.
Hi, I'm Katharina, a PhD student from UC Berkeley, and I have a question for a PhD student that's going to industry as an engineer or as a consultant. What does it mean to be a good, how does it mean to be a good in your role after a year? And how is your performance being evaluated? And if so, like what are the key traits that you guys will be looking for? Thank you.
Here, Dr. Abrams.
Oh, me, I was gonna let Charles go first.
No.
For some reason, I don't consider consulting industry. I don't know why.
Okay.
But because we kind of work in academia, we work for industry, even though I call us practitioners. And we don't hire many PhDs. We prefer, for the most part, the mid-range and smaller. We prefer, our workhorses really are bachelor's degrees and our master's degrees. Those are the ones that really get out, because as Charles said, it's a lot of projects. It's a lot of moving parts, and you've got to be able to grab things. And yeah, you can think about them, but you really can't. It takes a while, we found, for some of the PhDs to make this transition over to working as a practicing engineer. Some do it just like that, but it's more of the ones whose brains are wired to solving problems and making things work, and they can look at something and figure out what it is and move on with it. Other than that, though, you have a set of performance indicators that you have to meet. You meet those. You don't have to worry about anything. You've been very well trained, very well educated. And we try, at least in my company, I try to pair incoming new professionals with the professionals who have been there, and where I think that they're going to get the support that they need to adjust and to remain with the company. We are not someone that I push through. My company is about 46, 47 years old, and I have people who have been there 20, 30 years. So we try to take care of you as much as possible. So as long as you meet your performance indicators, you learn, you grow, you will be fine. And most of the firms that I work with, the small ones and the large ones, the consulting firms, I find them to be very easy and very supportive of their entry-level professionals.
So I say this to a lot of the PhD students that I've worked with that are going into a consulting position. You know, I say that the most important thing is to figure things out and produce quickly and effectively. And, you know, it turns out that maybe the hardest thing to produce is a paper that we submit for peer review. And everything else is not as hard as that. And so what I tell PhD students is be confident. You can figure out what needs to be figured out. And if you have been able to produce a manuscript for publication in, you know, a month or less, no problem. You can produce. That's the hardest thing there is to produce. And so now you just go do that, and you do it for 15 projects at once, maybe, but it turns out that by then it's really exciting. So I always say, don't stress. You know how to do this. If you've already done something that's immensely harder. Right?
Dr. Rosenfeld, did you want to answer this one? If you're speaking, you're on mute. Okay. We'll take another question.
Hey, I'm sorry. I think I froze. If there's an opportunity for me to answer that, I'd love to.
Yeah, please go for it.
I think I am echoing Charles in what he said with producing, but I would call it delivering. So delivering on the opportunities that you're given. And if you deliver, you'll be in great shape. The other thing I wanted to add, and this is specifically to PhDs and maybe specifically to my firm, one of the things we really value is entrepreneurship. I know that's sort of a vague term, but what it means is finding the hole in what we have and figuring out how to fill that hole with your expertise or with your management or whatever that seems to be. So I would say maybe not a year out, but within 2-3 years, we would love our PhDs that are really going to excel and become leaders of the firm to have identified some area where they're going to help lead us into a new space or a new expertise or something to that effect. So that entrepreneurship is critically important, especially for PhDs, because as we've said several times, that's essentially what you're trained to do
is find that gap in the science, find that gap in the knowledge and fill it. And, you know, so within consulting, the only thing we got to do is we have to fill it in a way that we can make money off of it. So that's all I've got.
All right, thank you. So we have one question coming up. We have another one queued. I want to make sure we get some questions from this side. So if you have a question, throw up your hand and we'll get you in the queue over here. But yes, please take it away.
Hi, I'm Mahdi, PhD student at the University of Buffalo. I have a question that as a PhD student or master student, all of us maybe have a good idea, you know, when we are pursuing our PhD or master. But after that, we just looking for a job as a consultant engineering or practical engineering. I have a question that, do you have any idea about starting a startup company that when I talk about the startups, many might go to the computer science engineering, but I'm talking about specifically environmental engineering startups that I haven't heard in the job positions there that you were talking about. Did you have any experience to invest on them, or as a industrial partnership, are you willing to invest on some of these high risk in startup companies or ideas that maybe many of these students have some idea about that?
All right, would any of our panelists like to get started on this question? Dr. Abron, yes.
Since I'm in business, engineering for the most part is a mom and pop operation. Engineering, accounting, and architecture. Our firms tend to be 5, 10, 20 people. 20 people for the most part is a big firm. My firm is about 85 full-time people, and we're called a tween. We're nothing like, you rarely see the big boys. So we're also low profit, right? It's people like this that won't let us make any money. So I'm teasing, but of course, everybody that's a municipal agency, they only have so much, so we only have a certain profit margin we can work within. So we don't have money for startups and to be angel people where we can provide money for you to be a startup. But there are opportunities within the federal government and within state and local government where you can start your own business. There are opportunities for small businesses, minority businesses. And then you have firms like mine who are willing to take you on as subcontractors to work with you. And a lot of our, quote, startup civil and environmental consulting firms, for the first couple of years, they work as subcontractors to other businesses. So that gives them the time and the opportunity to learn, to build up a portfolio, and then to stretch out. So you're rarely going to find angel investors in our business, but there are opportunities where you can get work to get started. And firms like ours, we're required to work with small businesses and minority businesses. So we do that. So you can look at it that way, and the opportunity is there. But trying to find an angel investor is going to be difficult.
I'm going to answer that question, not from the standpoint of a engineering firm standpoint, but from a technology provider standpoint. At HRSD, we're big enough and have enough budget to go looking for technologies and ideas that serve us. And maybe as a public utility, we're a little bit unique in this regard, but we're where the idea came from agnostic. So, my team and I, we go around to conferences and meetings like this and just looking for good ideas, good technologies that serve us to do better treatment, lower cost and smaller tanks, some benefit from a technical standpoint. And, we've supported several small companies to develop some ideas that we've deployed, and we're quite proud of that. We sometimes have some issues with public procurement requirements associated with doing that, but often, we can figure out a way to deal with that. Maybe the first step is writing a proposal together to get some funding for that organization to work together on a project, and then they demonstrate it and do the work at one of our facilities. So we'd love to do that kind of thing and support, but it really comes down to what's the idea, right? What's the technology, and does it provide a value? So provide a value to one of our facilities.
All right, and Dr. Rosenfeld, any thoughts on this question?
Yeah, a lot. Taking what Charles said one step further, we are also technology agnostic. We don't have any vested interest in technologies. We find that that's the best way to serve our clients the best. Well, we have a network of, and we have the ability to build bridges between potentially viable and exciting technologies and utilities that are searching for those solutions. So there is definitely relationships to be made, and part of our role as an innovators in the field is to identify those technologies that might be useful for one, more, multiple, many of our clients, and try to build those bridges between the innovators, the startups, the technology startups, and our clients that are searching.
Thank you. So we have another question in the middle.
Yeah, hi. I'm a PhD student from University of Illinois Urbana-Champaign, and my question is for our PhD student. Actually, our research is very specific, I would like to say. So it's mostly it's about maybe a very small aspect of technology, and how I just wonder how our research can be applied to our career, like how a so specific topic can be used in the future, like in my career, how it's related.
Our panelists want to jump on this one? Eric, do you want to start us off?
Sure, I can. I would just suggest keeping that larger perspective in mind. So every paper that I wrote on my PhD had a section, materials, introduction, materials and methods, the data, the results and discussion started by explaining the results, explaining the very narrow pieces that I found and explored, but then trying to broaden that into a context that wasn't solving the industry. It didn't have to solve everything, but it needed to have a practicality to it, whether it was creation of a simple model or application of a model through a case study or something like that. That practicality I found was really important in terms of building that bridge between the narrow and the impactful.
Any of our in-person panelists want to follow up, or should we move on? Okay, go ahead.
So, I think sometimes it's best as well that not to worry about that, right? So we maybe the approach should be to go into a new opportunity with let me work on something interesting. Maybe it's related to what I have been doing, maybe it's not. And if it's not, that's exciting because now one has an opportunity to go learn about a whole new topic and really dig in. And again, I think it's always important to remember that we should be falling back on the fundamentals and using the experience of how we've figured out how to learn in order to guide us down a new path. I know in my career, I had a period of 4 or 5 years where I went from one strange industrial wastewater treatment problem to the next, and they were all really unusual chemistries, completely different, requiring some kind of crazy stuff. And it had nothing at all to do with what I had done research in. And what I realized was that's great because I had figured out this other topic and I was interested in it, but that's fine. I got to do all these other really interesting things and go learn about a whole bunch of additional things. And so what maybe seems stressful is also a really good opportunity to take what you've learned and apply it in lots of other different areas. So.
Hi. Abraham, did you want to say anything on this one? No. Okay, we have time for maybe one more quick question, and we have one over here. So please just introduce yourself and where you're from first.
Okay, yeah. Hello, my name is Lan. I'm from NC State University. So my question is, what is the biggest difference between collaborating with your colleagues in graduate school and in industry?
Okay, would anyone like to start us off? Maybe I'll pick Dr. Rosenfeld in that case.
I think the focus on teamwork is the biggest difference. And you know, graduate school is often at its heart, sort of an individual process, right? You have to prove yourself, you have to prove your own thoughts. And yeah, you're working with your advisor, so that's not exactly true, but it is very much you're judged on your individual success. In industry, when you're done, it's the team, it's the bottom line, it's the reputation of your firm. And so with that comes a bigger responsibility, but you also have more resources and you can effectively leverage expertise and abilities of multiple people to make it work, to make the best solution come to life most efficiently. So I think that it's just a bigger team that when it works well can be really something special in terms of creating awesome solutions and creating them very efficiently in industry. Whereas it's more of an individual effort in academia, in grad school.
All right, thank you. So we just have 1 or 2 minutes. We want to make sure you have your break. So Dr. Bott, Dr. Abron, would one of you like to share some quick final thoughts on this question? Dr. Abron, great.
My situation is just so different because it was so long ago. But I enjoyed the collaborative arrangement or interaction with the graduate students, my fellow graduate students. I mean, when I got my master's, you did it in about 12 months. So you basically lived at school. I mean, you were there all the time. And so we spent a lot of time with each other. We knew everybody's wives or children, everything. And I was spoiled because I was the only unmarried female student. And so the wives really looked after me. So when they brought their husbands food, they brought me food. And when the professors had parties, we were all expected to be there. And since I was the only female, I was the one that got picked up and dropped off and the whole bit. So in a way, I was spoiled. So I truly enjoyed it. I was the only one that had a phone on my desk. We didn't have cell phones then. So I had a phone on my desk and I wasn't, you know, I had to when it was time. I was in school here when it was time to leave my lab. 1 o'clock in the morning, 2 o'clock in the morning, whatever it was, I had to call campus police to come and pick me up to make sure I got to the dorm okay and all. So I truly enjoy. I didn't have that when I went to work. So all of a sudden I was on my own. And even though I did have friends, I have to say that my graduate school was really wonderful for me. And I still had that same level of collaboration with my office mates, my professors and all when I started teaching, but not as close as it was in graduate school.
All right, let's give our panelists, all 4 of our panelists, a round of applause. So we have just about 10 minutes and then we'll start the next session. In here will be state and